Hello everyone, my name is Dennis Gladden and I will be conducting a virtual lab by identifying the unknown metal. Doing an internship at a jewelry laboratory, my job is to explore the properties of some alloys of silver, rhodium, and platinum in order to make brighter jewels at a lower cost. One day, I accidentally left the bottles near the melting furnace and the labels became charred and unreadable. However, I do know the density of silver is 10.5, rhodium is 12.4, and platinum is 21.45 grams per cubic centimeter. In this experiment, I will obtain the density of what are known to be the three unknown metals in order to label the bottles again. So, let's gather all materials that will help us to conduct this virtual experiment. I go into my tools section and I grab one scale. I go into my glassware and I grab a 50 ml graduated cylinder along with a 250 ml beaker. I go into my solutions and I will use the distilled water and lastly metal number 1. However, you can choose any metal to begin with. I want to find the mass of metal number 1, so I simply place my beaker on the scale, which then shows a reading saying that the weight of this beaker is 104.3103 grams. However, we don't want this. The weight of this beaker will affect the mass that we are going to be finding. So I tar it in order for it to become 0 back again. I place my metal here, which then gives me the option to be precise, sig fig, or realistic. I'll be realistic and pour in the X amount that I want. Which is the 43.5728. I now want to find my initial reading, so I place my distilled water here and the same process, realistic, and I click once to give me the amount that I want, which is the 10.83 millimeters. So the 10.83 millimeters is the initial reading. Now to find the final reading, I pour my metal into my cylinder. I click once and there was an increase of mass within my cylinder. So that increase surpasses 11, 12, 13, 14, and it lands in the range of 15. So 15 is the final reading. The initial reading is 10.83 and the mass is 43.5728. To get the volume of metal, we subtract the initial reading from the final reading, which gives us 4.17. To get the density, we simply divide the mass over the volume of metal, which gives us 10.5. And if you recall, silver is 10.5. So it's safe to say that metal 1 is silver. Metal number 2 will be conducted similarly to metal number 1, which is silver. To find the mass of metal number 2, we simply place our 250 ml beaker on our scale and we tar it in order to get rid of the weight of the beaker, because we're looking for the mass of metal 2. Now we're going to put metal 2 here and we're going to pour in X amount of metals. So I choose 38.9564 grams. To find the initial reading, I simply put my distilled water here and I click here once and it says 10.92 ml. To find my final reading, I now pour in my metal into my cylinder. And I click here once, and you can see there is an increase of volume. Increase of volume starting from 10 to 11 to 12 to 13 and stops at 14. So the final reading is 14. The mass is 38.9564. The initial reading is 10.92. The final reading is 14. To find the volume, we subtract the final reading from the initial reading, which gives us 3.08. To find the density, we divide the mass by the volume of metal, which is 12.6. So if you recall, rhodium is 12.4 and we have 12.6. So it's safe to say that the metal that we have here is rhodium. To find the mass of metal number 3, we simply place our 250 ml beaker on the scale and then we tar it to make sure it is at 0 grams. We do not want the weight affecting the mass that we are finding. Now we can place our metal number 3 right here and pour out the X amount of metals that you want. So I'll put 67.6600 grams. Now I want the initial reading, so I place this here and I click here once. As you can see, it is 10.52 ml. To find the final reading now, I add the metal to this graduated cylinder. I press the pour button. As you can see, there is an increase in volume. Okay, so that increase of volume range from 10.52 ml to 11 to 12, 13.52 ml. So our final reading is 13.52 ml. The mass is 67.6600. The initial reading is 10.52. The final reading is 13.52. To find the volume of metal, we subtract the final reading from the initial reading, which will give us 3. To get the density, we divide the mass by the volume of metal, which will give us 22.55. So, if you recall, platinum is 21.45, which is close to what metal 3 is illustrating. So we can say that metal 3 is platinum.